All right, we are in Chapter 4. This is Day 3 of Chapter 4, and today we are describing a translation and a rotation. And rotation is a word that's not, should I say, is not new to you, but translation might be a new word. So a lot of notes here. What we're going to need is a highlighter for this sheet. So this is our notes, and we're going to highlight some important terms. So here we go. Let's just get started. Sometimes there's more than one line in the picture, and we'd like to reflect a pre-image over multiple lines. So it's like we've got a picture, we want to reflect it over one line and another. When one reflection is followed by a second reflection, the combination is called a composite. I'd like us to highlight that right there. That's the definition of the word composite right there. When one reflection is followed by a second reflection, that is called a composite. And it's written like this: reflection over line M, fancy circle symbol, reflection over line N. This fancy circle symbol is said out loud as following. So this really says the reflection over line M following the reflection over line N. Now let's think about the word following for a second. Like if I said Dave is following Rita down the hallway, like Dave is following Rita, doesn't it mean that Rita is actually in front because Dave is following her, right? If the reflection of M follows the reflection of N, doesn't that mean you really reflected over line N first? So M following N means when they did these two reflections, they first took the picture and reflected it over line N, then took that reflection and reflected over line M. And I'll show you an example of that here shortly. But let's get back to our highlighting. So reflection of M following reflection over N is how it's read, which means the reflections are performed in the reverse order of how they're written. To describe a transformation, let's highlight this. To describe a transformation, we will fill out three things: the type, the magnitude, and the direction. What does type mean? Type, we figured that out. Type is either a translation or a rotation. What type of transformation are we doing here? So we'll figure out if it's a translation or a rotation by the kind of lines that are in the picture. And we'll see as we go on. Magnitude means how far does the pre-image actually move. I'll show you that. And the direction means which way did it move. So here's like a quick example. We're not even actually going to draw these transformations, but I just want to show you what it means because it's so confusing. People are like, what is going on here? So here I have a composite. This says reflection of B following the reflection over A of triangle DEF. Well, since B follows A, isn't it true that they took this triangle DEF and they reflected it over line A first? So it would look like this. Boom! They reflected this triangle DEF over line A. Got it. Then, once they've done that, accomplished that goal, they're going to take this new triangle right here, the red one, and they're going to reflect it over line B. Boom! So they did two reflections over multiple lines. And it just so happens that these lines right here are parallel lines. So what I want us to do is check out how things switch from the original purple triangle right here to the final green triangle. Doesn't it just look like that thing slid that direction, right? Orientation is the same if I go back to my pen here. Triangle DEF, counterclockwise, my bad. Triangle DEF prime, D prime, sorry, that's double prime, D double prime, E double prime, F double prime, counterclockwise. They have the same orientation. Because we flipped it over once and then we flipped it over again, it's going to have the same orientation. And this is a slide, which the fancy word for slide is called translation. We will not call them slides, we will call them translations. The reason why I knew this was a translation was by the type of lines in the picture. These lines were parallel. So as you see in our next problem here, it says a transformation will be a translation if it's a composite of two reflections over parallel lines. That's how you can tell when we're doing a transformation if it's going to be a translation, by the type of lines in the picture. If the lines were parallel, then this thing will turn out to be a slide, which we're going to call a translation. So that's the type. To find the magnitude, we'll measure the perpendicular distance between the parallel lines and double it. Let's just highlight this first. We're going to do our highlighting first, and then we'll kind of explain. The reason why you want to measure the distance between the parallel lines and double it is because how many reflections did we do? We did 2 reflections. So we moved it once, let's say that was 1 inch, then we moved it, reflected it twice, so there's another inch. So that from the purple to the green, it actually moves 2 inches. It moved twice this distance between the 2 lines. And we'll get there when we get there. So that's magnitude. And lastly, we need to figure out the direction. The direction of a translation, we're always going to use this generic phrase, perpendicular from blank towards blank. All we'll have to do is fill in the blanks. But when we fill out direction, we will always use this phrase, perpendicular from blank towards blank, and we'll fill in the blanks with the names of the lines in the right order as we go along. Okay, so let's try one. First off, I want to know what type of transformation is. Here they give me the composite, right? It's all about this composite right here. They just asked me to describe composite. Let me write it down first. They just asked me to describe this guy, means fill out the type, magnitude, and direction. That's all we're going to do. We're not even going to do any reflections. So the type is determined by the kind of lines in the picture. We've got line G, got line H, and aren't they parallel lines? So, booyah, since I'm doing a composite of 2 reflections, 1, 2, over parallel lines, that will be a translation. The magnitude. They said they need you to measure the perpendicular distance between those parallel lines and double it. So, first thing we do, extend out one line very much longer. There, I've extended out my line very much longer. Second thing we do is let's place our geometer on top of that line with the black line of our geometer on top of that line that we extended out very much longer. So get your geometer, put the black line on top of that line, and it doesn't really matter where you line that edge up. I'm not concerned about that, but don't put it in the way of like the actual triangle or whatever polygon you're trying to do the reflections with. So let's just put our geometer on there, and wherever that edge is, here's what we're going to do. We're going to just draw a segment between those two. Just connect the 2 lines together with a segment. That's all we're going to do. And you can remove your geometer then. So connected those, and what happened is this segment, because we used our black line on this, that black line's perpendicular, so I need us to put a little right angle box, meaning that this is the perpendicular distance between the 2 lines. Like, you just don't want to measure like any distance between the 2 lines. It's like from there to there. It's like, well, that's not perpendicular distance. You want to measure the perpendicular distance, so that's why we're going to put this little segment on here. Now, just take the centimeters part of your ruler of your geometer and measure how far is that little segment. How long is that little segment? In centimeters, just how long is that little guy? So, when you measure that, hopefully you got that to be about 1.6 centimeters. Now my picture is obviously different than yours, but I'm using the actual piece of paper. So on your piece of paper, that thing should have measured 1.6 centimeters. Okay? To remind us what we're doing again here is we're trying to fill out the magnitude. And how do you find the magnitude again? Magnitude is we will measure the perpendicular distance between the parallel lines. We just did that of 1.6 and double that distance. We're going to double that. Oops, wrong way. We're going to double that distance. 1.6 doubled is 3.2 centimeters. Don't forget the label of centimeters. If you just put 3.2, I'm going to mark it wrong. Why are we doubling that distance again? Remember, it's like we did 2 reflections. Purple reflected to red, red reflected to green. That thing moved twice the distance. So if this was 1.6 centimeters, so move 1.6, then it moved another 1.6. That's why we have to double that distance. Okay? The last thing we got to do is, not the last necessarily, but we're going to fill out the direction. Direction, every single time it's going to be this phrase, perpendicular from blank towards blank. We're going to write that in here, perpendicular from blank towards blank. And now all we have to do is fill in the blanks. What goes in the blanks is the names of the lines. We need to put the names of the lines in the blank. H and G are the names of the lines. So, the only thing that we need to figure out is which goes where. Where does H go? Where does G? It depends on which one comes first. When reading the composite, doesn't this say H is following G? H is following G. If H is following G, which one comes first? Well, G is coming first because H is following it. So this triangle ABC, if I reflected it, first I'd reflect it over line G, balut, then I'd reflect it over line H, balut, and it would end up over here. This triangle just slid 3.2 centimeters perpendicularly from G towards H. The last thing I want us to do is circle which line comes first in its actual name, like there's the name of the line G, and draw an arrow perpendicularly-ish. You don't have to measure it, but don't draw an arrow like this. Okay, draw an arrow that's going at basically a right angle from this line, and saying that this triangle right here, if I was to actually do this translation, it would slide 3.2 centimeters this direction, perpendicular from G towards H. We're not even actually going to do the translation. We are just describing it today because it takes too much time. It takes too much time, and when we take our test, people just wouldn't get finished because we just, it takes too much time, So that's all we're doing. This is a translation. Why? Because there were parallel lines in the picture, and it's a composite of two reflections over parallel lines. Magnitude, measured that perpendicular distance and doubled it. Direction, perpendicular from blank towards blank. G comes first, and circle G and make an arrow going that direction. Let's try again. Here's a composite of two reflections over these two lines. What kind of lines are they? They're parallel lines, so that means that that's going to be a translation. A translation is a composite of two reflections over parallel lines. Magnitude, extend out one of these lines very much longer, and then put your geometer on there, and measure that perpendicular distance. So when you get that segment drawn in there, okay, go ahead, extend your line out longer, measure that perpendicular distance, which I've already done. That distance perpendicularly should measure about 3.5 centimeters. I'll give you some leeway, about 1/10 of a centimeter. If you had 3.4, 3.6, that's all good, but just measure, start with 0 on your ruler, and just see how long is that thing. So that means the magnitude would have to be twice that, which is 7.0 centimeters. Direction, perpendicular from blank towards blank. And now all I have to do is fill in the blanks by reading the composite. You do that by reading the composite and figure out which line comes first. If J is following K, that means K comes first, J comes after. Since K comes first, circle K, and that thing's going to go that way. This dude right here, this quadrilateral, would slide 7 centimeters that direction, perpendicularly from K towards J. Fantastic. Those were translations, because the lines that we were reflecting over were parallel to each other. Now obviously, if we're in the same plane and two lines are not parallel to each other, that means they intersect each other, correct? So that's when we'd get a rotation. So back to our highlighter. Let's highlight some information. A transformation will be a rotation if it's a composite of two reflections over intersecting lines. So it's all about the lines in the picture to tell the type. Parallel lines means translation, intersecting lines means rotation. So then the magnitude will be determined by measuring the non-obtuse angle and doubling it. When we say non-obtuse, it means not obtuse. Most people would say measure the acute angle, measure the acute angle. The legal way to say it is to say non-obtuse, because it could be possible that the angles in this picture would actually all be 90 degrees, and those are not acute. So it's like measure the acute angle. It's like there are no acute angles, so that's why we say non-obtuse. And then the direction will once again be determined by the composite, but let's just skip that for right now. We'll come back to it, and let's try one. Okay, so here's one. Do you see the two lines in the picture? Intersecting, correct? They want me to describe this transformation, which is a composite of two reflections over intersecting lines. So type, going to be a rotation. Because of the intersecting lines, that's how I know this is going to be a rotation. The magnitude, they say measure the non-obtuse angle. Well, do you see this angle right here? Looks bigger than 90 degrees, so that's obtuse. We want to measure the non-obtuse angle. You have two choices. This angle right here or this angle right here, angle 1 and angle 2. Which one should you measure? Does it actually matter? Should the measure of angle 1 equal the measure of angle 2? Should those measure the same amount? You bet they should, because those are vertical angles. And the vertical angle theorem says so. So what I want us to do is measure angle 1. And here's how I want you to do it. First thing you're going to have to do is extend this line B out a little bit longer. So let's do that. And you'll see why in a second, but let's extend that puppy out longer. Good. Then take the whole of your protractor, you know, that thing down there, and place it on this point right here with the black arrow on top of this guy right here. Put the whole of your protractor on where the two lines intersect and place a black arrow on top of this particular one and just measure where does this dude come up to. And you should get somewhere very close to 60 degrees. And when you get that 60 degrees, you know, if you had 59, that's fine. If you had 61, that's fine. But that should be what you measured very close to. So I'm filling out the magnitude. Again, let's see what this is. The magnitude is measure the non-obtuse angle and double it. Remember, we're doubling it because you're doing two reflections. Keep going backwards. Double it because you're doing two reflections. First you're going to reflect it over A, then you're going to reflect it over B. So 120 degrees is the magnitude of this rotation. The direction, well, we haven't read that yet, so let's go back and let's grab our highlighter. The direction will once again be determined by the composite, but for rotations we have two possible choices, clockwise or counterclockwise. I guess I didn't want to highlight that, my bad. To determine this, let's circle the name of the line that comes first according to the composite and draw an arrow towards the other line through the non-obtuse angle. So it says circle the name of the line that comes first, so let's go do that. According to the composite, it says B is following A, right? If B is following A, which one comes first? A does, so circle the name of the line that comes first. Then it said draw an arrow towards the other line through the non-obtuse angle. So I'm going to put two choices down for you. I'm going to draw this arrow towards the other line, right? That's line B, or I'm going to draw this arrow towards the other line. Both of those arrows are starting from this A and going towards the other line of B. The question is, which choice is through the non-obtuse angle? Is it the blue one or is it the red one? Well, this is the non-obtuse angle, right? It's not obtuse, so that means this dude right here is wrong. That's the wrong way. This is the correct way. Don't make this arrow keep going further and further around. Just draw it to that line and stop. And is this arrow going clockwise or counterclockwise? That's going counterclockwise. So that's the direction of this thing. One more thing to figure out. Counterclockwise, is that positive or negative direction? Counterclockwise is positive, so that means we keep this magnitude to be a positive 120. If it was clockwise, then we have to go upstairs and make that thing a negative 120. So let's recap. How did I know it was a rotation? Composite of two reflections over intersecting lines. Magnitude, measure the non-obtuse angle and double it. Direction, figure out which line comes first. Which one did you reflect over first according to the composite? Circle it. Draw an arrow towards the other line through the non-obtuse angle, and that will tell you your direction. Counterclockwise positive, clockwise negative. Uno mas, my friends. So find the non-obtuse angle and measure it. I would measure this guy right here. You'll have to extend this out. If you don't extend that out longer, then this arrow won't reach the top of your protractor most of the time. So extend that out longer. Measure this angle. Whatever you measure the angle at, you got to write it in there. So 60 degrees again, they don't all turn out to be 60 degrees. It just so happened that these two problems were both 60. So filling out the type, it's a rotation, obviously intersecting lines. Magnitude, double that, 120 degrees. Direction, circle the line that comes first. If Y is following X, that means X comes first. And now I want to draw an arrow from that circle towards the other line through the non-obtuse angle. So wouldn't that be right there? Doesn't this arrow, isn't it inside the non-obtuse angle and it goes right towards the other line? And that's going clockwise. And clockwise is negative, so we got to go up here and put a minus 120. Yeah, buddy. Those 4 problems were just describing it, We didn't actually do any rotations or translations. We just figured out if we would do them, here's what would happen. This guy would be a rotation. It would actually rotate a negative 120 degrees clockwise. Here, they want us to actually do a rotation. And you notice there's no lines in the picture anymore, which is kind of goofy because that's what our whole system was based on, the first 4 problems. But these are the only rotations that we'll actually do. I think it's good for us to do a rotation since it's a geometry class. We need to learn how to use a protractor a little bit. So still, let's start with type, magnitude, and direction. Type, real easy. It's going to be a rotation. How did I know it's going to be a rotation? Well, because they told me so. They said, please rotate this. So that means it's going to be a rotation. They say rotate ABCDE, that's this dude's name, a negative 110 degrees about point P. So my question to you is the magnitude going to be a negative 110 or is it going to be a negative 220? Should I double that number? Here's a good analogy here. If I said, hey man, please give me $5, would you give me $10? Well, why'd you give me $10? Well, because you said the number 5. And I doubled it because that's what we've been doing. It's like if they say rotate something to negative 110 degrees, you don't double that. You do what they tell you to do. Back in this problem, we had to double this because they didn't tell me how much to rotate. We had to figure it out, and that's 2 reflections over an intersecting line, so we doubled it. So when they tell you straight up, please rotate this at negative 110 degrees, the magnitude is going to be a negative 110 degrees. There's no doubt about it. When they tell you how much to rotate it, no doubling. If you have to figure it out by way of lines and all that stuff, you have to do the doubling technique. Now direction, clockwise or counterclockwise? Clockwise or counterclockwise? If they say negative 110, that means clockwise. Then what I do is I'm going to draw myself a helper arrow. This dude right here is going to rotate clockwise. So got myself a little helper arrow to realize which way should this thing actually go? It should go down here. Okay? Now, here's what we want to do. First thing we want to do is we want to rotate it about point P. They got point P right here. We're going to measure 110 degrees clockwise with our geometer. There's no way that we're measuring anything. There's no such thing as a negative 110 degrees. But how we'll do that is we'll take our geometer and we're going to flip it upside down. So since I don't have a visual, here's your geometer. It says the geometer on it, and here's your little protractor down here. What you need to do is just flip it completely, not turn it around, but flip it over to where the words that you see at the top are backwards. The phrase the geometer, you're like looking through it and it's completely backwards. So flip this thing over to where all the numbers and everything are backwards. You can't see, it's just complete backwards. Okay? So because it's clockwise, negative means flip it backwards. You want to read the numbers backwards. Cool? Take just your straight edge and let's rotate this point A. I'm going to pick this point A and rotate it a negative 110 degrees from point P. Here's how we're going to do it. Take your straight edge and connect a segment starting from P through A. Starting from P through A, just like that. Don't go down here. Don't put any segment down here. It's going to get a very confusing picture, but just connect from P through A right there. Is that okay with you? Then what I want you to do with your geometer face down, right, backwards, with your geometer backwards, place the whole of your protractor on top of this and the black arrow on top of this segment that we've just placed. Put the black arrow on top of that segment that we just placed right there. Whole of your protractor on P, black arrow on top of that guy. I know this is a little confusing. If you're watching the video and you need some help, please come in. But whole of your protractor on top of there, black arrow. Now, you should be able to find 110 on your protractor, which is down here somewhere, and the numbers are backwards. Put a little tick mark wherever 110 degrees is, and just do that. Find the 110, and it should be somewhere down here. Put that tick mark. Once you got the tick mark, take your straight edge and connect a line from P through there to where it'll end up looking just like that. There's where my tick mark was for 110 degrees, just right there, and I connected through there. Then I put a capital A just down here. Draw that segment nice and long. Don't stop it where your tick mark was. Draw it nice and long, and just put an A down there. That's which one of these segments belong to A. I took this angle right here measures 110 degrees, and we went this direction, so that's really a negative 110 rotation. That's all we've done so far. Put an A there, because we're going to do that again for B, we're going to do that for C, we're going to do that for D, and we're going to do that for E. So let's do it for B. Let's connect from P through B. Many of you, depending on the thickness of your pencil, it was like the exact same segment. Mine was just a little bit off, but however you measure it, if it was the exact same segment, then again, measure 110 degrees and put a little guy that belongs to B down there. That's a B. Cool. Do that again for C. Connect a line from P through C and measure 110 degrees away from that. Then do it for D, and then do it for E. Like I said, if you're confused, please come see me. Just stop what you're doing and go, I don't understand how to do this rotation. Come on in and I'll show you. So there, I've done that. Here's in green C, this is D, and this is E. My picture got cut off. And that was a B there. Look at that beautiful B. Are we all good? Okay, that is half of it. Now we actually have to put the prime points. So here's how we're going to do that. Let's grab our ruler. Okay, let's grab our ruler, and we're going to measure this distance right here from how far is just this little distance from P to the original A. How far is that? How are we going to measure it? We're just going to take our ruler, put the 0 part of your centimeters guy on P, and just measure how far that thing is from A. Okay, so measure that real quick. And I measured it on the piece of paper. Don't trust this ruler right here, but wasn't it about 1.4 centimeters? About 1.4 centimeters. So what that means is now we're going to measure 1.4 centimeters away from P on this new line that belongs to A. Remember, we're moving A. We're going to measure 1.4 centimeters on that. Get our ruler all lined up with it, and we're going to put a dot, and that's where A prime is going to be. So here, 1.4 centimeters, there, 1.4 centimeters. Put a big old fatty dot and call that A prime. Now do that again for B. Measure how far from P to B is originally. From P to B is. From P to B, hopefully you got about like 2.6 centimeters. I think I measured that right. So then go on the line that belongs to B and put 2.6 centimeters away. And do that for C, D, and E. Just measure how far away is it with my ruler. Go to the line that belongs to it and put those points on there. That's the prime points. And when you're all said and done, you can now connect the dots together. Go blue, and actually I'll go something that I can see. How about purple? Get out of the way. So A to B, can't see that. B to C, C to D, D to E, E to A. And then what you could do if you're all said and done, these two guys should look exactly the same. Remember, this is a transformation, and transformations preserve angle measure between this collinearity and distance. Okay, it's still like two reflections, but orientation is also preserved by these, because if you check it out, A, B, C, D, E, if you go from A to B to C to D to E, that goes around clockwise. A, B, C, D, E prime here, when you rotate it, that goes clockwise. So there's actually 5 things preserved by rotations and translations. They preserve the ABCDs, angle measure between this collinearity and distance, and they also preserve orientation. So if you want, you could highlight this, since there's all these dang pencil marks and it's kind of confusing, or darken it in a lot darker with your pencil so you can see the final loop. Don't erase any of those lines. I want to see them. That's how I know if you did it correctly or incorrectly. So that was a rotation. If it was, remember, that was rotation, negative 110 degrees, clockwise. If it was counterclockwise, you do the same thing but with your geometer right side up. So the trick was, did you have your geometer the right way? What totally sucks is if you do all that work and you did it the wrong direction because you had your geometer facing right side up or upside down the wrong way. So be very careful that you're doing that. Put that helper arrow. Doesn't it look like that thing rotated that direction? So give it a shot. If you need some help, please, I'm more than willing to help you, and have a great day.